Today's lesson is how to describe quadrilaterals. Now you don't need to write this down because we've already got it in our notes from a previous lesson. We can classify quadrilaterals into different groups. We have the trapezoid subcategory, which has exactly one set of opposite sides that are parallel. We have our kite subcategory that has one set of opposite angles that are the same as each other, and the two top sides are the same length, usually shorter, and the two bottom sides are the same length, usually longer. And then we've got parallelogram subcategory. And parallelograms have two sets of parallel lines. Opposite angles are the same, and opposite sides are the same length, which means that rectangles are a type of parallelogram. Rhombuses, or rhombi, are types of parallelograms. And squares are not only special types of parallelograms, but also special types of rectangles with 4 right angle corners, or 90-degree corners, and types of rhombuses, or rhombi, that have all 4 sides the same length. And of course, there are those irregular, funky quadrilaterals out there too. So today, based on what we know about parallelograms especially, let's see if we can crack some codes out there and figure out some mystery angles and some mystery sides. All right, time to start writing down. This will be example A. Let's say that we've got a parallelogram, and the name of that parallelogram is ABCD. That would mean that the 4 vertices, or vertexes, or corners of the parallelogram would have the points A, B, C, and D. Let's draw that. So if I'm drawing a parallelogram, I think I'm going to start with my opposite sides so that I can get those parallel. And I'll connect these, and these should be parallel as well, if it really is a parallelogram. And the 4 corners are labeled A, B, C, and D. So the name of this parallelogram would be parallelogram ABCD. ABCD. Yeah, awesome name. Now, if the length of side CB, or we could name it BC, is 6 meters, based on what we know about a parallelogram and the rules of a parallelogram, that must mean that the opposite side, looking across it, AD or DA, would also be 6 meters. Now write that down. That also means that if side AB is 14 meters, what else do we know? Side DC is also 14 meters. So we've talked about our side lengths for a parallelogram. Opposite sides are always going to be the same lengths as each other. Now let's talk about which sides are parallel to each other. You should be able to write this in a math sentence using these symbols, like for line segments from one point to another. But let's talk about which sides are parallel. Side AD is parallel to side BC, and side AB across the top is also parallel to side DC. Another thing that we can decode if we know it is a parallelogram is the angles. Now I'm running out of room, you just continue in your notes down below. Well, we know that opposite angles, or angles that look across at each other, are going to be the same if it is a parallelogram. So this angle is the same as this angle. So if we knew the measurement of one of these angles, we would automatically know the measurement of the other. Pretty cool. So let's say that angle ADC, or you could say angle CDA if we're talking about this one. The D, though, has to be the middle letter because that's the point where the angle comes together. If angle ADC is 50 degrees, then what else do we know? That this angle right here, angle ABC, or you could also name it angle CBA, as long as the B for the corner, the vertex of the angle, is in the middle, that's fine. Then that's 50 degrees also. Now here's where it gets really cool, and this is a little bit above grade level using algebra, but I totally know that 5th grade brains can handle it, so I'm going to go ahead and teach it to you. We know that the other pair of opposite angles, or angles that look across from each other, are also the same measurement. Not necessarily the same measurement as the others, although they could be. That would be a rectangle. But they've got to be the same measurement as each other. Now, if all we knew was that this angle ADC was 50 degrees, we actually have enough information to find out all 4 of the missing angles. We already figured out one of them. Think, if ADC is 50 degrees, and so is ABC, if we add 50 and another 50, we get a total of 100 degrees. And the cool thing about any quadrilateral that you have is that all of these inside angles, the angles that are on the inside of the shape, will always, always, always add up to 360 degrees. The same number of degrees as in a circle, because it goes all the way around. Be sure to write that cool fact down, because we're going to use it in our upcoming above grade level algebra problem. So, if our 2 red angles add up to 100 degrees, and we know that all 4 together will add up to 360 degrees, we kind of have an algebra problem here. 50 degrees plus 50 degrees plus x plus another x, same variable because it's the same angle measurement, equals the grand total of 360 degrees. Well, is there anything we can do yet? Yeah, there is. We know that the 50 and the 50 makes 100. And it looks like we have 2 of the same thing. We have 2 groups of x, or 2 times x. And that'll all add up to 360 degrees. So how much do we have left of this total of 360 degrees? Maybe we need to figure out, once we take away the 50 and the 50, or take away the 100, how much is left. So let's take away 100. That's going to cancel out. So now we have 2x equals whatever 360 degrees minus 100 degrees is. I'm running out of room. You keep going down below. Which means that 2 of angle x, whatever it is, are going to equal our remaining 260 degrees of our 360 degree total. So that means the double of something, or 2 of something, equals 260 degrees. Or what plus itself, what doubled, or what times 2, all different ways of thinking about it, get 260 degrees. So basically, we're cutting 260 degrees in half. We're dividing by 2. And we will get a very squished x equals 130 degrees. That means that we have 130 degree angles here, which makes sense because they are obtuse angles greater than a square corner, greater than 90 degrees. And if we plug that in and test it out, we can add 50 plus 50 plus 130 plus 130, and we will get 360 degrees, which is pretty cool. So the cool thing is that based on what we know about a parallelogram, and its opposite sides being the same, opposite angles being the same, and opposite sides being parallel to each other, we could be provided with just a little bit of information, like a couple of side lengths and one angle measurement, and we can figure out everything else. Let's add in a couple more facts that we didn't write before about the measurements of these angles. So if you know you have a parallelogram, all you need to know are the two different side lengths and one angle measurement, and you can figure out everything else. Check it out. This will be example B. We're going to be working with a rhombus, and we're going to name it BEST, or best. Now we're going to have to use what we know about a rhombus, or rhombi, plural, to help figure out all of the things that we could find out about the lengths of the sides, which sides are parallel to each other, and even the angles. We know that in a rhombus, all sides are the same length, so if we know one side, we know them all. But first, let's label our points, our 4 points for the corners of the rhombus. Mathematicians usually start in the top left and kind of label in a circular fashion, going clockwise. B-E-S-T, rhombus, best. Say we only knew one side length. Say that side SE was 4 yards. Then, what else do we know? Because it's a rhombus, then so are sides ST, TB, and BE. Because for a rhombus, a special kind of parallelogram, all the sides are the same length. Also, we know that since it's a rhombus, the opposite sides, the sides looking across at each other, the opposite angles looking across at each other, are the same measurement. Not necessarily all 4, although it could be, but at least the opposite angles have to be the same as each other. Our cool trick about quadrilaterals is that all the angles will add up to 360 degrees, so we only have to know one of them. So let's say that this angle right here, angle EST, or you could write angle TSE as long as the S is in the middle. Then we also know that the opposite angle, angle EBT, as long as B is in the middle, or TBE, as long as B is in the middle, is also 135. Now that leaves us with these two angles to figure out. We know they're the same as each other, and we know that all 4 will add up to 360 degrees. So let's see where we're at so far with getting to 360 degrees. 135 plus another 135 would be 270 degrees. We know that that 270 degrees, when added with our 2 other angles, we'll call that measurement X. It's the same thing. We'll make 360 degrees. So how much do we have left to get to 360? Go ahead and keep writing below this. I'm out of room, so I have to erase though. On a number line, our problem would look like this. Starting at 270 degrees, we have to eventually get to 360 degrees. And we're going to add 2 x's. 1, 2 x's to get there. We know they're the same amount, so we can subtract to find the distance in between. We can subtract, or we can add on to get to 360 degrees. We could do 360 minus 270, or we can add on. Either way, I'll show adding on. I can use compensation here. If I added 100, that would get me to 370, and then I could go back 10 to land on 360. So that would be 100 forward and 10 back, which would be 90. That means that when I add these two angles together, I get a total of 90 degrees. So what would be the measurement of each angle by itself? Cut it in half. Then I have, out of my two x's, I've got one x here and another x here. If the whole thing is 90, cut 90 in half, and each x is going to be 45. So that missing angle measurement here and here is 45 degrees, because 45 plus 45 is 90, and 135 plus 135 is the 270, and 270 plus 90 will get us to 360, that magic quadrilateral angle measurement number. Look at how much we were able to sleuth out like a detective by just knowing, to start with, one side length, knowing what we know about rhombi, one side length, and one angle measurement. That's all we needed, and we could figure out all the side lengths and all the angle measurements. And there's one more fact that we should write about parallel sides. Our top and bottom sides that are opposite each other, BE and TS, are parallel to each other. If it's a rhombus, a special type of parallelogram. And our other sides, I guess the left side and right side, BT and ES, those opposite sides are parallel to each other as well. So just by knowing a couple of facts about these special types of quadrilaterals, we're able to figure out all the rest. Task time! You are going to make up example C using some sort of a parallelogram. It can be a special type of parallelogram like a rhombus, a rectangle, or a square. Although rectangles and squares, when you're figuring out the angles, they're kind of giveaways since they're all right angles. They will still add up to 360 degrees though. Or if you really want to challenge your partner tomorrow that you're going to trade with, do a parallelogram or even a special type, a rhombus. What you're going to do is you're going to draw some sort of parallelogram. You can use this as an example, but I encourage you to make up your own numbers. Draw some sort of parallelogram. It could be this, it could be another one from your imagination, as long as it really follows the rules of being a parallelogram. Come up with your 4 points. You can make it spell something if you want, as long as it's school appropriate, of course. And give tomorrow's partner just enough information that they'll be able to figure out some of the facts. Now, you need to figure out the facts too. So, for example, if you gave a couple of different side lengths, that would mean you need to figure out what the other side lengths are too and write that down. And if you just give one angle, you also need to figure out the missing angles too. So figure out the missing side lengths and missing angles of your parallelogram. Remember, you can do a rhombus if you'd like. Make sure that it has a name and the points are labeled, and you'll be sharing these tomorrow. Have fun designing and looking for those missing numbers. And we'll see you tomorrow.